Alright, hello Chem 1 students. Today we're going to try to run you through our virtual measurement lab. Okay, so here we go. Remember what's important. Are you using an analog or a digital device? That changes how you write your measurement down. Okay, so you may want to remember there's some key things about writing down measurements before we get started. Okay, so we got 6 stations. What we're going to do, Mr. Moore and I are just going to walk you around the stations and try to give you a clear look at them, much like if you were here in class. It's the same lab as if you were here, essentially. So come on over here. We'll start with station A. All right, so station A says to measure the volume of this block. Well, I don't know, if I'm going to be able to do that directly, but I do have a ruler here. It's marked off in inches and centimeters, but we prefer to use centimeters, of course. And it also has graduations at the millimeter marks. So let's see if we can get this so you can have an accurate reading of the dimensions of the block.
I'm going to step to the other side of you.
I think I have to hold the ruler maybe to... Okay.
Okay, I'm going to move this over. We can see that over here we're at the 0 mark on the left, and on the right
Okay, have you been able to read it? There's one dimension. Okay, I'm going to rotate the block. Okay. Oops, slid on me. Okay. Okay, one more dimension. Okay. All right,
Mr. Hubble.
All right, so again, station A is, let's find the volume of this block. Okay, on to station B.
Now, do we need to put units on our measurements too?
I don't know, what do you think?
I guess. If we just have numbers, they don't really mean much unless they have a unit.
I guess units are important. It's a little different than math class when you can just write 5,
right?
And everybody knows what that is.
Mm-hmm.
Good point. Okay, let's see. Here's station B. They would like us to measure the volume of this solid. Well, what I have is the solid cylinder, and I have a graduated cylinder.
That looks like solid gold, that cylinder.
Isn't that great?
Is that one of yours?
I think it is. Yeah. I yanked one out of my strong box.
Yeah, it's going to be one of your teeth someday.
Yeah, there you go. Okay, so here we go. I'm going to measure the volume.
Oh, yeah, okay.
Is that going to work, Mr. Moore?
Well, it's a graduated cylinder. It's supposed to measure volume, right?
Yeah.
But if you give it a shake, it seems like there's some of the volume that's not being occupied by the graduated cylinder.
Oh, that's a problem.
Yeah. What do we do now?
Now we need a plan B. Have you ever heard of measuring volume by water displacement?
I think so.
I think so. So what I'm going to do is step over to the faucet over here, and I'm going to put some water in here.
Set it down, yeah.
Yep, we're going to need an initial volume here.
Oh, I guess it is a little bit hard to see. We see the 15. Okay, can we catch that meniscus? Do the best you can with that. I think you can see it. Okay, so yeah, you see where the 10 and the 15 marks are. Get an initial volume. Now go ahead and put the cylinder into it.
How many decimal places? I mean, you got to think about this.
Yeah.
Right, you got to be careful how you write this measurement.
The cylinder has graduations every whole milliliter.
Remember, there's a proper way to write this measurement. Since this is the measurement lab, I'm guessing if you make a mistake with this, it's not good. Okay?
Right.
So now, here we go. Let's add the cylinder. I'll try to do this without splashing water out.
Okay, so now it has the volume of the cylinder in it. Of course, it has gone up to that. Just going to give this another rotate. Hard to see when we only have the yellow in the back.
Do you need a different background?
No, I think,
Just more?
I don't know if it helps if I do that.
Because I could put a board behind it or something.
Yeah, go ahead and grab that board over there and see if that helps. Maybe, I think it does. Okay, so we had a beginning volume and then drop the cylinder in and we have an ending volume.
Yep, station B.
So I think we have to subtract 2 measurements. We have a rule for that.
Oh yeah, that's right. There's so much to think about.
Mm-hmm.
Okay, I'll keep the board with me just in case it's
Okay.
helpful.
Yeah.
Okay, here you are. Here's station C. It wants us to simply read the volume of the liquid that's in the cylinder. What do you think about the
So
board,
yeah, we can
Mr.
see
Moore?
30 and 40. Let's go ahead and put the board back there. I do think that that helps. So, yeah, do the best you can. Look at how this thing is graduated. Let's see. All right, read the volume of the liquid.
Here we go, station C. All right, we're halfway home. We got 3 more stations. This one is similar. Station D is similar to station C. Measure the volume. The only thing is, this is a different graduated cylinder. Make sure you look closely at the graduations.
Would you rotate that
Which way you
toward
want it
you, the numbers toward you just a little bit? Okay, that's good. Thank you. Do the best you can on that. Look at how the graduations are on this one compared to the last one. Get the volume of that liquid.
Okay.
All right.
All right, onward. Okay. Here's station E, and it says measure the mass of the green liquid. Usually it's blue, this year it's green. Okay? So, here we go, we have our digital scale here. Now you may remember the other day we looked at 3 different digital scales.
Mm-hmm.
Okay. I wonder how I can accomplish this.
Yeah, if we just pour that liquid right on the balance, you think it'll all sit there and let us measure its mass?
Oops, we lost the lights. Hold on.
We can see fine. It's all right.
Yeah, I don't know. I'm guessing that's not a good plan, Mr. Moore.
I think some of it'll.
I think
come
some
off.
of it'll roll away. So that is not a plan. I don't know. Are these beakers identical? I mean, could I do this? There's the mass of this empty beaker.
Empty beaker is 65.07.
Okay. I'll put the beaker with the fluid on.
Okay, so with the fluid, that beaker is 140.57.
Okay, was that a legitimate way to get the mass of the liquid? Using those two measurements.
Well, they both look like they're the same size beaker, doesn't it? In fact, they both say 150 milliliter.
They do. This one has blue writing, this one has white.
Yeah.
I can't say they're exactly identical.
I think they're even different brands.
They
So
are.
probably not.
That may not be the
exact
best
same
way to
mass.
go.
Yeah.
Oh, but you know what, Mr. Moore? These balances have what's known as a tare function, where on the balance it says 0. The balance can be zeroed with an object sitting on there. So I could put the empty beaker on there, hit the 0 button, maybe. Okay,
Oh,
now
yeah.
the balance is zeroed with that beaker sitting there, and then what if we did this?
All right.
Okay.
We got it.
All right. One final station. It's not uncommon for us to have to read temperature. I don't know if we'll need the board.
Mm-hmm.
But this station F is simply saying, can you measure the temperature? So here's one of our standard thermometers. Can we see it?
Yeah, I can see it fine. Looks like there's a red liquid in it. I thought thermometers had mercury. Is that a mercury thermometer?
Yeah, this is not a mercury thermometer. Unfortunately, the state of Michigan won't let us have mercury thermometers.
Yeah.
Go figure, mercury's toxic. So I don't get it. But
Yeah.
this is called a spirit-filled thermometer. And so there's a red liquid in here, so if the thermometer breaks, we don't have to worry about a mercury spill.
Right. Okay, so just can you turn it away from you a little bit, so we can see the numbers in here. So you can see that the numbers go up by tens. Boy, it's not focusing very well.
No, it's
I'm
not.
focusing
It's
on the
blurry.
wood more than the.
Oh, let me move the wood.
let's try it.
Get rid of the wood. Maybe I
See if
should
that
not
makes a
even hang on
difference.
to it.
Oh yeah, I think maybe we can catch it like this. That does help. So yeah, we can see it's between 20 and 30 now. Can we read the temperature?
Right.
It's still not focusing though.
Yeah, it's not doing a good job. I wonder why.
You should be able to see that. It's not perfectly sharp,
Right.
but pretty good.
Okay, now remember, when you write down your measurement, it's important to write the measurement correctly. All right, that's the big deal in this lab. And in case you missed the hint earlier, units are important.
Yep. And some of our measurements are calculated now, so we want to round to the correct number.
Right,
of
yeah,
sig-figs.
and there could be some calculations that you have to do. Remember, there's rules for how you handle significant figures when doing calculations.
All right, Mr. Hevel.
Mr. Moore, I think it's a winner.
Good lab.
Great lab.